You know, it feels like we're living in an age of pure magic, right? AI can whip up these incredible works of art from just a few words, translate languages instantly, and even drive our cars. It really feels like these systems are just pulling amazing results right out of thin air.
But hang on a sec. Is it really that simple? Is all of this incredible power actually a free lunch? Or is there some kind of hidden cost, something quietly piling up under the surface that we just can't see? That's the big question we're going to dive into. Well, it turns out a pretty legendary paper from some Google researchers gave us the perfect way to think about this. They said building machine learning is kind of like using a high-interest credit card. Yeah, you get all the cool stuff right now, but behind the scenes, you could be piling up this huge, invisible, and super expensive debt.
So what is this technical debt thing anyway? It sounds a little scary, I know, but it's a really, really important idea if you want to understand how software gets made, especially AI. So let's break it down. Basically, at its heart, technical debt is just the tech world's version of taking a shortcut. Picture this, you're building a bookshelf. You could just slop it together with some glue in like an hour. And hey, it works for a little while. But you know, deep down, that sooner or later, you're gonna have to go back and do it right with screws and everything. All that future work you just made for yourself, yep, that's the debt. In this slide, it draws the parallel perfectly. It's just like financial debt. With a credit card, it's buy now, pay later with your money. In the world of software, it's launch now, refactor later. And refactor is just a fancy word for paying to clean up your own mess with your team's precious time and energy. And get this, just like interest on a credit card, the complexity compounds. It gets harder and harder to make changes. And as we're about to find out, AI systems, man, they are absolute pros at racking up this special, super high interest kind of debt.
Okay, so if our AI is a credit card, what are the big ticket items that are maxing it out? Let's take a look at the 3 biggest charges that are pretty much unique to the world of machine learning.
All right, charge number 1. This is a big one. The paper calls it entanglement, and it boils down to this simple and honestly kind of scary idea they call CACE. It stands for changing anything changes everything. The absolute best way to think about this? A game of Jenga. Seriously, an AI model is like a giant Jenga tower built out of thousands of different bits of data. Engineers call these features. Now, in a normal computer program, all those blocks are kind of separate. But in an AI, oh no, they're all tangled together. So if you try to pull out or even just wiggle one tiny little data block, the whole tower can start to wobble in ways you just can't predict. Or worse, it could come crashing down. It makes trying to improve an AI a super high-stakes game.
Okay, on to the next charge. And this one is my personal favorite because it's just so sneaky. It's called hidden feedback loops. This is what happens when an AI gets so good at its job, so good at interacting with the real world, that it actually starts to change the world it's supposed to be learning from. Wild, right? The paper gives this perfect example. Let's say you've got an AI that recommends news articles. And one of the pieces of data it uses is how many articles a person clicked on last week. Simple enough. But now you make the AI better. It starts giving fantastic recommendations, and so people start clicking on more articles. So the AI looks at this new data and basically thinks, whoa, people are clicking on way more stuff. That clicks per week thing must be super important. And it starts to change its own logic based on a trend it created. It's this slow, creeping change that can totally warp how the system behaves over time, and it is a nightmare to try and figure out what went wrong.
And that brings us to our third big charge, something the authors beautifully call pipeline jungles. You see, the actual learning part of machine learning, that's just the tip of the iceberg. The huge, massive part of the work is just getting the data ready for the AI. You know, cleaning it, mashing different sources together, formatting it just right. That whole system for preparing the data is called a pipeline.
And this leads to a number from the paper that is just mind-blowing. In a lot of big real-world AI systems, what percentage of the code do you think is the actual smart part, the algorithm? Take a guess. It's only 5%. Just 5. The other 95% is what's called glue code, this messy, tangled-up jungle of code that does nothing but shuffle data around. And trying to fix or change anything in that jungle, it's a total nightmare.
So there you have it. We swipe the credit card, we've got entanglement, feedback loops, pipeline jungles, our system is up and running fast, and it seems to work. But eventually, that bill is going to show up in the mail. So what happens when it's time to pay up?
So what's the real price you pay for all this debt? This chart lays it out perfectly. It's basically a tax on innovation. Look, a team with a low debt system, they get to spend their time building cool new stuff, pushing the boundaries. But a team that's drowning in debt? They spend almost every waking hour just fixing bugs, wrestling with complexity, and basically just trying to keep the whole thing from falling apart. They're stuck paying interest on their debt instead of investing in the future. And in the worst-case scenario, the cost can be absolutely catastrophic. The paper brings up this infamous story about a company called Knight Capital. They lost, get this, $465 million in 45 minutes. And the reason why? A single piece of old, forgotten experimental code. A ghost charge on their technical credit card that somebody accidentally turned on. And poof, disaster. That's the ultimate price you can pay for letting complexity run wild. But look, this isn't all just doom and gloom. It's not meant to scare you. The good news is that just like with a real credit card, there are smart, responsible ways to manage this debt and even pay it down. So, how do we do it? The authors basically give us a financial plan for building healthy AI. First up, regular audits. You gotta constantly check what data you're using and throw out anything that isn't useful anymore. Think of it like cutting up old credit cards you don't use. Next, you have to isolate your experiments. Keep your new wacky ideas separate from the main system so they can't cause trouble later. Third, you've got to think about the whole data pipeline from day one, not just the cool, smart algorithm. Fourth, you have to monitor everything all the time. Watch how your model is behaving out in the real world so you can catch those sneaky feedback loops early. And last, treat configuration as code. All that means is that you need to be just as careful with your system's settings as you are with the code itself, because one wrong click can be just as bad as a huge bug. See, it's not magic, it's just good, solid engineering.
So, when you boil it all down, the big takeaway is this. Building really great, long-lasting AI isn't just about coming up with a genius algorithm. That's only a tiny part of it. The real challenge is an engineering one. It's all about building systems that can handle all this insane complexity, that can change and grow safely, and that won't just collapse under the weight of their own hidden debt.
So the next time you use an AI to write an email or create an image, maybe you'll stop and think for a second about what's really going on behind the scenes. You might wonder about that invisible Jenga tower holding it all up and the incredible hidden work that goes into making sure it doesn't all come crashing down. The magic is definitely real, but now you know it's built on a solid foundation of really smart, disciplined engineering. Thanks so much for joining me.